Okay, so you've heard the term data science thrown around everywhere, right? From business to healthcare, you name it. But what does it actually mean? Well, today, we're going to pull back the curtain on one of the most powerful fields that's shaping our entire world.
To get us started, I want to ask you a question. For the last century or so, the answer to this was pretty clear. But today, right now, in our digital age, what do you think is the world's single most valuable resource?
If you were thinking of something like oil or gold, well, you're not wrong, but you're thinking of the past. Today, the new resource that's shaping pretty much everything is data. And, just like crude oil, raw data isn't all that useful on its own. The real value, the real power, comes from refining it. And the people who can do that, they're in higher demand than ever before.
So, to really understand data science, we first have to get a handle on its raw material. I mean, what is data, really?
Think of it like this: the number 72. That's it. Just 72. It's just data. It has no meaning whatsoever by itself. Is it a temperature, a test score, somebody's house number? Who knows? On its own, it's just a raw, completely unorganized fact. It's only when we start to process this raw data, when we analyze it and give it some context, that it becomes useful information. So for example, if we learn that 72 is the number of positive customer reviews we got today, suddenly it's not just data anymore. Now it's information we can actually act on. And that journey, from raw facts to meaningful insight, well, that's the absolute heart of data science.
And the discipline that's dedicated to making that whole journey happen, that's data science. But I'm sure you've heard other terms thrown around too, like artificial intelligence and machine learning. So let's chart this territory for a second and see how they all fit together.
Okay, so at its core, data science is the discipline of turning all that raw data into insights we can actually use. Insights that help us solve really complex problems and make smarter, more informed decisions.
Now let's kind of zoom out of it. Data science operates inside this much, much larger field called artificial intelligence, or AI. You can think of this as the big overarching goal, creating machines and systems that can do things we normally associate with human intelligence. Stuff like reasoning and learning.
And inside of AI, we have this incredibly powerful subfield called machine learning. And this is where things get really, really interesting. Instead of having to program a machine with rules for every single possible situation, we just give it a massive amount of data and let it figure out the rules for itself.
And believe it or not, this isn't some brand new idea. All the way back in 1959, a computer scientist named Arthur Samuel gave us this perfect definition that still holds up today. It is all about giving computers the ability to learn from experience, or in this case, to learn from data.
Probably the easiest way to think about this relationship is to picture a set of those Russian nesting dolls. AI is the biggest, outermost doll. You open it up and boom, inside you find machine learning. You open that one up and you'll find even more specialized fields like deep learning.
And these ideas have been brewing for a lot longer than you might think. I mean, the basic theory of an artificial neuron goes all the way back to 1943. We already mentioned Arthur Samuel coining the term machine learning back in '59. But the world really took notice in 1997, when IBM's supercomputer Deep Blue beat the world chess champion Garry Kasparov. That was the moment that proved machines could learn to strategize at a truly world-class level.
Okay, so we know what data is, and we know the key disciplines. But how does this process actually work? In the real world. Let's get practical and walk through the step-by-step journey a data scientist takes on any given project.
So every data science project follows this life cycle, which is kind of like a roadmap. It always starts with defining the goal. Then it's about collecting the data, cleaning it up, exploring it to see what you've got, building a model, and finally presenting your findings. It's a structured, repeatable process every time.
Now let's just pause on step 3 for a second, because this is way more important than it sounds. Data in the real world is almost never perfect. It's messy, it's full of errors, it's incomplete. Imagine trying to analyze customer addresses where some have zip codes, some don't, and a bunch are misspelled. A huge chunk of a data scientist's job is just cleaning up that mess so it can be used for anything meaningful.
And then there's step 5, model building. This is where a lot of the magic people talk about with AI actually happens. This is where we use those machine learning techniques to build a model that can find hidden patterns or even predict future outcomes based on all that nice, clean data we prepared.
So to actually navigate this 6-step journey, a data scientist needs a pretty specific toolkit.
What are the foundational skills you actually need to become one of these modern-day digital explorers?
It really all boils down to 3 core areas. First, you need a solid foundation in mathematics. Second, a really good grasp of statistics, which is all about making sense of data and uncertainty. And third, you have to be able to code. Programming is the language you use to command the data.
And inside that mathematics bucket, there's one area that is absolutely essential: linear algebra. I know it might sound intimidating, but it's basically the engine running under the hood of so many of these powerful algorithms. Think of it as the grammar for the language of data. It gives us the rules to handle massive, complex data sets in a really efficient way.
Okay, so we've covered the what, the how, and the who. Let's bring this all home by looking at the why. What does all this work actually achieve out there in the real world?
The applications are, well, they're literally everywhere. When your phone compresses a photo to save space, that's data science at work. When your streaming service recommends a movie you might actually like, yep, that's data science too. It analyzes your viewing history, compares it to millions of others to find patterns, and ultimately makes our digital lives way more personalized and efficient.
So at the end of the day, we've built these unbelievably powerful tools for finding answers buried deep in data. The technology is just incredible, but it can't tell us what to look for. And that leaves us with the most human challenge of all, figuring out what are the right questions to ask in the first place.